Math 3, Unit 9, Section 3. This is the second part of 9.3 notes. Okay, so we're going to be working on solving logarithm equations. Some of these equations you will know how to solve. You'll know the answer by just looking at it, which is fine. But for the ones that you don't look at and know the answer, you'll want to use these instructions. So you'll set the equation equal to, actually you're going to make it an equation by setting it equal to x. Then you'll rewrite it in exponential form. Once you do that, you would want to rewrite them to have the same base. Then we will drop the bases, just like we kind of did yesterday, and then solve for x. So we'll kind of work through this process on one that we know the answer to. Because if we look at this one, it's saying 7 to what power is 49? And what is that answer?
7.
It's 2. Okay, but let's work through this process just in case. So what I meant is you would end up saying this equals x, okay? And then we would rewrite this in exponential form. And so we would say that would be what? 7 to the x power equals 49. Then we would want to rewrite these with common bases. So 7 to the x equals 49 is 7 to the second power. Then you can drop the bases and x equals 2. On a problem like this, if you know the answer, I'm okay with you not going through this process and putting that the answer is 2. Okay? On this problem, do you guys know what this answer is? It is -3, but we're going to go ahead and go through this process as well. Okay? So again, I would set this equal to x. We would rewrite this as 3 to the x equals 1 over 27. Can I turn 27 into base 3? Yes. We know that 27 is what? 27 is 3 to the third power. And then in order to make the bases be at the same level, we would need to bring that up. And what happens when I bring it up? Very good. It becomes a negative exponent. So we have 3 to the x equals 3 to the -3. We drop the bases, and that means that x equals what? -3. Okay? This next one, again, we're going to go ahead and set equal to x. How will I write this one? So same thing, right? What is the base? So we have 5 to the x power equals what? Very good, 5 root 5. Now, right now, these are all 5s, but you need to basically condense this right here and so that it's just 1 5. Okay? So this 5 right here is really 5 to the first power. How do I rewrite this one? We want to keep it as 5.
No.
Yes.
Wouldn't that be more 25 times 5? Because if you simplify it, it'll be about 9 because there's 2 of them and then another 5 left.
Not, well, yeah, you mean like this could be the square root of 125?
Yeah.
Yes, that could be another way of thinking of it, yes. If I'm just looking at it how it's written here, though, how could I change root 5 to just be an exponent instead of a root? How can I change root 5? 5 to the 1/2. Okay? Because this is a square root, so this, if there's no number there, that's actually a 2. And this 5 is to the first power. Okay? And so we write that as 5 to the 1/2. Now, when you have two numbers with the same bases being multiplied together, do you guys remember what you do with the exponents? Yeah, you add them. So what's 1 plus a half? 1/2, or 1 1/2. 5 to the x equals 5 to the 1 1/2. So all we did there is added 1 plus a half in order to make 1 1/2. Now, when you're seeing these answers, and then if we drop the bases now, it's just x equals 1 1/2. Most of the answers, though, they won't have it as a mixed number. They would change this into an improper fraction. And so you would probably see this answer as 3 over 2. And remember, you changed mixed numbers to improper fractions by taking 1 times 2, which is 2, plus 1 makes 3, 3 over 2. But either answer is acceptable. Okay, so this next one, we're going to go ahead and use the same process. We'll put equals x. So when we rewrite this, it will be what? 5 to the x equals the cubed root of 1 over 25. What base will I use on this one? 5. Good. And so what I would do is I would start by changing the 25 to be a base 5. And so 25 as base 5 would be what? 5 squared. Good. Okay, and so now if I want to get rid of that fraction, what do I do? We move it up, and so it would end up being what? A negative 2. Okay, so I have 5 to the x equals the cubed root of 5 to the negative 2. And then what would I do now?
Negative 2 over 3.
Very good. Change it to exponential form. And so we have 5 to the x equals 5 to the negative 2 over 3. So our root number always goes in the denominator, and the exponent, our power, goes in the numerator. So therefore, my answer is x equals negative 2/3. Okay? Next one, we're going to put equals x. I'm going to give you about 30 seconds here to try this one on your own. When you get your answers, go ahead and show me on your fingers. Okay, so how did we set this one up? 1/2 to the equals, what's going to be the base? 2. Okay, how do I bring this 2 up? What exponent does the 2 have right now? A 1. So when I bring it up, it's going to be what? Nope. Negative 1, right? So you bring it up, it's going to be negative 1, and then you're going to multiply it by what the power that's already there, which is x. And so that's actually just negative 1x. And 16 is 2 to what power? 2 to the 4th. And then we can drop the bases. We have negative x equals 4. Divide by negative 1 to both sides, and we get x equals negative 4. Okay, I want you guys to give this one a try on your own. See if you can. Okay, what did you guys get?
4.
Good, yeah, so that means that x actually equals what? 2.5, good job. So when I set this one up, you should have got 4 to the x equals 16 root 4. I can change 16 to base 4, so we can keep everything as base 4. 4 to the x equals, 16 is 4 to the second, and the square root of 4 is 4 to the, nope. Oh, so this is 1 and this is 2, right? And so it becomes 1/2. When we have like bases that are multiplying, we add the exponents, and so we end up with 4 to the x equals 4 to the 2.5, which means that x equals 2.5. Well done. Okay, last problem on this set. Natural log we know is always what base? Base E. And so we have natural log of base E of 1 over root E equals x. So when we set this up, what happens? How will I write it? E to the x equals 1 over square root of E. Now, the square root of E, if we want to get rid of the root, how will I rewrite that? E to the 1/2. Well done. But we want to move it up to the same level, and so when we bring it up, very good. E to the x equals E to the negative 1/2, which means that x equals, very good. Any questions before we move on? Okay. Now, just like when we had like bases on each side, we could cancel out the bases, correct? It works the same with logarithms. If you have the exact same logarithm on both sides, but it has to be one single logarithm on both sides, you can cancel out the logarithms and solve the equation. So do you notice here how both of these are log base 2's? So we can cancel out the logs, and your equation just ends up being 3x equals 96, and then we will solve. Very good. So we'll divide by 3 to both sides, and x equals 32. Okay, go ahead and give this second problem a try. When you get the answers, show me on your fingers. Good. Oh, that was right for this one. Next one, right here. Oh, just kidding. I have a different problem on my... Okay, so, sorry, I had a different problem I was looking at on my thing. Okay, so, cancel out the logs. What do we get? 4 equals x over 7. Next, what will I do?
Multiply 7 on both sides.
Very good. These cancel out, and x equals 28. Okay, I apologize for telling some of you that you're incorrect. You're correct. Okay, next problem. Are the logs the same on both sides? And it's a single log on both sides. Okay, so that means we can, good, cancel out the logs. So now I have 9 to the x power equals 27. What am I going to have to do at this point? Very good, get like bases. And we're going to have to break them down to 3's, base 3, because 27 cannot turn into base 9. Okay, and so 9 is 3 to what power? 3 to the second times x, 3 to the third power. So now we have like bases, which means I can cancel them out. And my problem ends up being 2x equals 3. And the last thing to do to solve would be to... Very good. And so my answer is perfect. X equals 3 over 2. Again, do I have a single natural log on both sides? Yes? So we can cancel them out. Okay, my equation is 3x plus 7 equals 4x minus 8. What will I do now? So we can do things multiple ways. I'm going to go ahead and subtract 3x to both sides. That cancels that out. I have 7 equals x minus 8. And the next thing I would do is add 8. Very good. X equals 15. Okay, is this a single log on both sides? So can I cancel it out? No, we can only cancel them out when we have a single similar log on both sides or a single base on both sides. So what would I do to solve this problem? What other strategy do we know? Very good. Change it to exponential form. So we would write this as 3 to the second power equals 4x plus 5. Can we solve this now? Yeah. What is 3 to the second power? 9 equals 4x plus 5. Then we will do what? Very good. Subtract 5 to both sides. We have 4 equals 4x. And then the last thing we would do is, good, divide by 4, and x equals 1.
Wait, how did you get 3 squared again?
So we change it to exponential form. And remember, that's why it's saying like 3 to the second power equals that. Okay? All right, what natural log is always what base? No, natural log, e. Very good. And so do I have a single log on both sides here? No. So what am I going to do? Change it to exponential form. Very good. So when I write this one in exponential form, what will it be? E to the fourth equals x minus 3. Good. Now, e to the fourth, you could actually figure that out by using your calculator. We know that this is an irrational number like pi. Okay, but for this problem set and on your homework and stuff, if you ever have anything in terms of e or pi, just leave it as e and pi. Okay, so we don't have to simplify this. So the last thing I do in order to get x by itself is what? Just add 3 to both sides. So the answer is x equals e to the fourth plus 3. Do we have questions? Okay. Now logs are what base if it doesn't state it? Good, base 10. Do I have a single log on both sides? No. Nope. So what am I going to do? Change it to exponential form. Okay, what will this be in exponential form? 10 to the x equals, so I'm going to write this first just as the fifth root of 100. What base will I end up using? 10. 100 is what? Very good, 10 to the second. Since there's 2 zeros, we know that that's 10 times 10, so 10 to the second power. How will I end up rewriting that in exponential form? 2/5. Very good. Again, the root goes in the denominator and the power goes in the numerator. Then we can drop the bases. Very good. All right, last one. Can I drop the log? No. What will I do? Oh, go ahead. What were you going to say? Say that again. No. So this one, they're saying we don't know what it is. So know that this could be any base. Yeah, I can see it. But yeah, so what we're going to do is rewrite this in exponential form. So how would I do that? X to the 2/3 equals 25. Okay. How do I get rid of that 2/3 exponent?
X equals square root of 25 to the third, or 3 cube root of 25 squared.
Close. Yeah, actually you're right. I was having to think through it. Okay, x to the 2/3. What will I do to that though? No, not cry. That's the wrong answer. That will not help you. What would eliminate 2/3?
3/2.
Yeah, 3/2. That's what Tigran was saying, but in a different way. So, do you guys see here how this reduces, cancels out? Okay, so now what? How can I simplify that? This is what Tigran said. Not cubed root. Square root of 25 to the third power. Right? This number is the root. That number is your exponent. What's the square root of 25? The square root of 25 is 5. And then 5 to the third power is 5 times 5, which is 25. And then 25 times 5 is 125. That's your answer. Okay, any questions?